right, so so these kinds of questions where you're asked for which values of k will f of x equal to k have three distinct roots. Three distinct roots or three unequal roots, the same thing. Distinct means not the same. Roots are your x-intercepts, okay? Roots are your x-intercepts. Remember, whenever you are solving for x and you get your x values, your roots, your solutions of x, we call those roots. Roots are also called x-intercepts. So here's the thing. What you need to first have is you need to have your stationary points. You need to have your coordinates for the stationary points, number one. So what do we need to have? We need to have our coordinates for the stationary points. So we have them. If you don't have them in a particular graph, please find them first. So our first stationary point there is -3 and 51. And then the other stationary point is 2 and 0. And then what we do is we have an intense focus on the y values of the turning point. And the reason why that is the case is because, look at this. If we're saying f of x is equal to k, all right, if ever the k is on this side, please transpose it so that you can see f of x means y. That's what f of x means. F of x means y. For which function? For the cubic function. So if we are looking at y, the y values of the turning point, then we are going to ask ourselves, in this function, where do we see us having three distinct roots? So in other words, three x-intercepts, right? So currently we have two x-intercepts. But look at this. If we were to move this horizontal x-axis, all right, up, okay, if we were to move it up, all right, you can see if that line was there, we'd have three distinct roots. Three distinct roots, because the line, the x-axis, cuts through 1, 2, 3. So the minute we are above this turning point, we have those three distinct roots.